Let's take a look at the 8 queen problem we did in class. So remember, the idea was to place 8 queens on a board in such a way that no queen could take off any other on the very next move. So what we see over here on this board is a solution. So in fact, if you take a look at it, let's say for example this one right over here. So this 6, remember what the representation was. This 6 means that in column 0, right, this is column 0, in row 6 there's a queen. This 4 over here means that in column 1, right, this is column 0, column 1, column 2, up to column 7. So in column 1, there's a queen in 4. Right, so here, this represents a complete solution. Now, there's a couple of things to notice about this. First of all, notice that I have all the numbers from 0 to 7. There's no duplicates at all. What would a duplicate mean? Let's say, for example, instead of there being a 6 over here, there were a 0, right, in this position right over here. Instead of there would be a 6, which means that there's a queen on row 6, there'd be a 0 here. Well, the 0 here would mean that there's a queen in this position here, but that would be no good because that queen would conflict with this one here, right? So what you see is that if I give you a representation, we call this thing over here, we call this Q. If for any of the elements of the list Q, I have the same number twice, like for example, here I would have a 0, and here would have a 0, that would mean on some row I have 2 queens, and that would be no good. So remember the algorithm said start generating all of the possible values of 8 values from 0, 0, 0 to 7, 7, 7. So one thing that you have to make sure of when you examine one of these configurations is you check through every one of the elements in that list, and if you've got 2 of the elements are the same, then right, if 2 numbers are the same in there, then you know that it's not going to be a valid configuration. Okay, so that's one thing to check. So one of the tests that we have to make when we look at a configuration, every time we generate a new configuration, is, as we just saw, is there any duplication of the numbers in the array Q? Here you see explicitly I've labeled the array with the Q as the label. That's the name of the list, and on the top, very top, you have the column numbers. So what that gives us, the duplication of numbers on the array, on the list Q, gives us the ability to detect if there are 2 queens in the same row. But that's not the only problem that could arise. The other problem that could arise is 2 queens in the same column. But because of the way that we're generating these configurations, that can't happen, right? Because what we're doing is we're generating sort of a base 8 number with a different value in each one here. So there's never going to be a case where I have 2 values in the same row. If this means 5, right, that means in this column, in column 4, there's going to be a queen in row 5. In this representation, there's no way to put 2 queens in here. So we don't have to worry about that. We saw now look for duplicates to make sure there's nothing in the same row. In terms of the column, we don't have to worry about it. But what about the diagonals? We saw if I have 2 queens on the same diagonal, that's a problem because the queen also controls the diagonals that she's on. So over here, this is actually a solution, so there are no 2 queens on the same diagonal. But how do I detect the diagonal? Let's say, for example, I have a queen over here. So if there's a queen over here, I now have a conflict in the diagonal because from here I can go directly down here. So how, using the representation, can I in fact detect this? All right, so first of all, notice that this is a diagonal. However, the following is not a diagonal, right? If I would take a queen and move, let's say, from here to, let's say, this way, this would not be a diagonal. Likewise, this would not be a diagonal. The diagonal has a characteristic that every time I move down one box, I move over one box. I move down a box, I move over the box, right? So that gives us a hint about how we could detect whether 2 queens, say this one and this one, are a diagonal conflict. What I look for is really a triangle that looks like this, right? Notice I have to come down this way, and if you look at how many positions I move down and how many positions I move across, they really are the same. So for example, over here, I move down 1 and 2, and then across I move 1 and 2. So that means if I have two queens, say the ones that we see here, this queen and this queen are in a diagonal, it's going to be the case that the distance between them on the rows is equal to the distance between on the columns, right? The distance over here is the same as the distance over here. So how do I actually detect that, right? So first of all, what number would be in my array Q for this queen here? Instead of there being a 7, there would be a 2 over here, right? There's going to be a 2 there. So this 7 would now be, forget this guy, right? There would be a 2 right over here, right? And so what the 2 is telling me is that in column 5, there's a queen in column 2. So if I look at how do I get the distance between the columns? Well, what column is this? This thing here is column 5, right? This is column 5 over here, right? These are the column numbers. That's column 5, and this one here is column 3, right? This queen is in column 3. So what's the distance between these two? We see that I have to go from here. I have to go 1 and 2. Well, 5 minus 3, that's 2. So this distance is 2, right? 5 minus 3. But what about the row distance? How do I tell what the distance in the row is? Well, this guy, right, this one right over here, he's in column 0. And this one over here, that's in column 2. So if I look at the difference between the columns, this being column 2, this one here, and this one over here being column 0, so 2 minus 0 is also equal to 2. So this difference here is equal to 2, right? This difference here is 2, and this difference over here is also 2. So when I'm comparing two queens, or actually I don't even know about the queens, when I'm comparing two columns, what I'm really looking for is to know, does this one over here conflict with this one over here? I don't have this picture. This picture doesn't appear in my representation. All that appears in my representation is just the array Q. So if you point to two positions in this list and you ask me, do these represent queens that are diagonal, it's very easy to tell. I simply take a look what the column number is, right? That's the index. This is position 0 in the array Q, position 1, position 2, and so on. So this is position 5 and 3. The column difference is the 5 minus the 3. The contents of Q, right, that tells me the row number. So if the column difference, 5 minus 3, is equal to the row difference, which is the contents of this minus the contents of this, well, then I have a conflict. If I want to say this, in Python, it might look something like this. So to check for a diagonal conflict, let's call this column over here, I'm going to call this column C, right? So in this case, column C is column 5, and we want to compare column C against column J to see if there's a conflict between the queen in column C and the queen in column J. So if you look down here, this test in Python will do it. Why is that? Because C minus J, the right-hand side of this question, of the equals, is the C minus J is this value here, which is 5 minus 3. So 5 minus 3 is 2. So this is the difference in the columns. Now Q sub C is the row that the queen is in column C. So it's the 2, right? And Q sub J is the row value of the queen in column J. So Q sub C minus Q sub J is the difference in the rows. So what this is asking is the difference in the rows equal to the difference in the columns? And that's what we saw characterized as diagonal. This is the difference in the columns, this is the difference in the rows. If this is equal to this, then a diagonal. So we see basically that in order to detect if two different columns if there's a conflict here, so we have to really make two tests. The first test is, do we have two queens in the same row? That was the first situation we looked at. For example, if there would be a 0 over here and a 0 over here, that would mean in row 0 there are two queens. There would be one here and one here. If this were, for example, a 3 and this were a 3, this would mean that there's a conflict here because this guy here is in 3. There'd be one over here. So the first test we need to do is a duplicate test. That means every time I generate a new list Q from my generator that we saw the last time, that we saw in class last time, I examine that to test for duplicates. Now, if it passes that, if there are no duplicates, then I have to check for every column against every other column, is there a diagonal conflict, right? Just like we looked at over here, What I need to do is I need to check, take for example, column 7. Does anything conflict with column 7? So I have to say, well, call column 7 C, and then check every one of the columns against column C to see if this guy here is C now. For example, looks like I would have to test every column against column 7. I would have to check to see whether column 0 conflicts, whether column 1 conflicts, when column 2 conflicts, to check each one against column 7. So does this one conflict, does this one conflict, does this one conflict, and so on. So let's say, what does it mean conflict? Is there a diagonal conflict? So I have to say, is 7 minus 0 equal to q sub 7 minus q sub 0? If that's true, that would mean that there's a conflict between this column and this column. If there isn't any, I have to check 7 against 2. Is 7 minus, against column 1, is 7 minus 1 equal to q sub 7 minus q sub 1? And I check all of these against 7. Now let's say there is no such conflict here. So then I move back, then C, instead of being over here, C moves over here. Right? So now 6 is going to be C. And I do the same thing. I check 0 against 6, 1 against 6, and so on. If there is a conflict, then I know that there's some diagonal problem here. If there isn't, I move C over here, right, to 5, and then check 0 through 4 against 5. And if I keep doing this and I never find a problem, that means it's a good configuration. So for example, take a look at this what we have here on the board, the correct one. So if I look at this particular queen, there's a queen in column 7, there's a queen in 3 here, right? So what I look at is I take a look at 7 minus 0. Well, 7 minus 0 is 7, right? 7 minus 0 is a 7. So the difference between this column and this column is 7. But the value in here minus the value in here, well, it's 6 minus 3. What is 6 minus 3? 6 minus 3 is 3. It's actually 6 minus 6. I'm 3 minus 6. 3 minus 6 is minus 3. But I'm only interested in the absolute value. So we really have to test absolute value. Because this thing is here, so from here to here, right? From here to here, it's a distance of 3. So from 7 to 0, the column difference is 7, but the row difference is only 3, so there is no conflict. So this one doesn't conflict with this one. How about this one with this one? Of course it doesn't conflict, but these are actually a configuration. Right? So that's why this thing works. But let's say, instead of there being a queen in column 1 in 6, let's say there would have been a queen in column 1. Well, I couldn't have a conflict between these two because it can't reach, there is no diagonal. But for any of these things, if there would be, let's say, for example, this one has no diagonal conflict here. But if there would have been a queen here in 7, then the one in column 6 and the one in column 0 would conflict. Why would that be? Because this would be 6, and that would be a 0. 6 minus 0 is 6. And if this would be a 1, and this would be a, right, go down here, that would be a 7. So 1 minus 7 is minus 6, but I'm interested again in the absolute value, so that gives me 6. So the 6 would match the 6, and it would be a conflict. That's basically how to do this. So here you see an example of 3 functions that we could use in the program, right? Basically, remember what the idea was. The idea was we're going to have some kind of loop, and the loop is going to go from 0, right? For n over here, what we're going to pass into n is a number, right? A number, let's say, going from 0 up to 8 to the 8th. And what get next is going to do is going to change that number, that base 10 number, into a list with 8 values representing, a base 8 representation. In other words, numbers, the list will have 8 elements, and every element is going to be a number between 0 and 7, right? And so it's going to count up from 0, 0, 0, 0, 0, 0, 0, up to 7, 7, 7, 7, 7, 7, 7, right? So get next will give us the next list representing a possible configuration, and then every time we generate one of those things, I have to do both of these 2 tests. The first test is going to be, is there going to be any duplicates? I check to see if any number appears twice. How do you do that? But if there are duplicates, so get this duplicates is going to return a true. What are we going to do if it returns a true? Well, we're going to reject that list, right? Because that's going to be a situation where there's a 0, say, in some column, and a 0 in a different column. So that means that means there's 2 queens in row 0. If it would contain 2 5s, that would mean in some column there's a queen in column 5 and another column is a queen in column 5. So any duplicates would mean that we have to reject that configuration. But let's say this returns a false, right, which means that there are no duplicates. That still doesn't mean we're home free, because it could mean that there's a problem on the diagonals. So this is the easy test. We should do this test first. If we pass this test, we have to come down here to diagonal threat. So we pass in that same, what is Q going to be? Q is going to be that list of 8 values, right? And we're going to test this Q, as we saw in the previous slide, to check if there's a diagonal conflict, right? 2 queens occupying the same diagonal. If there is, it returns a true, and we're going to reject. Otherwise, we're going to return a false. So that means returning false means we pass this. If we return a false, it means there's no duplicates. If we return a false here, we pass this. And that configuration, right, assuming that it's true for all the values, not just 1 and 1, but for the duplicates, that tests the whole list. Diagonal threat, remember, has to check each one against every other one, right? We start over here and do everything to the 7th one. Then we move over, look at the 6th one, and check from 0 to 5. Then we move over to 5. We check from 0 to 4 against 5, and so on. That's what the diagonal threat's going to do. If this says no problem and this says no problem, we can accept the configuration. And now here we have the complete program, right? So this part of the program down here is the sort of the main program. And so we start counting. We start num equals -1. And num is going to be the number that we're going to then make into a base 8 number. Count is equal to 0. This is going to count how many solutions we have. And so we say while num, which is -1 when it starts out, is less than 8 to the 8, immediately I say num equals num plus 1. So since num started out as -1, num immediately becomes 0. We feed that 0 into the getNext function. That converts it to a list, which represents the base 8 value of that 0. What's that going to look like? That's going to be 0, 0, 0, 0, 0, 0, 0, 0. That's what Q looks like. It's a list with 8 zeros. And now we do those 2 tests. If it's true that there are duplicates in Q, then we're going to continue. What does continue mean? Come back up to the while loop and get the next number, right? But if it turns out that duplicates is false, which means we found no duplicates, there weren't any 2 elements in the list that were the same, which would imply that there were 2 queens on the same row, we now do the diagonal threat. The diagonal threat is checking the whole configuration of that list with 8 values to see if there's any diagonals. If there is a diagonal threat anywhere in there, again, we're going to reject that and we'll continue, go back up to the top of the while and get the next number. However, if this turns out to be false, in other words, there are no duplicates, and there's no diagonal threat, then we now count one more. Remember, count started out at 0, now count becomes 1, and we say solution number count, solution number 0 is, and we print out the solution, which is in Q, and then what do? We come back up to the while loop and get the next count. That's basically the way the program works. So what you really need to do is, using this main program, write these 3 functions: getNext, and duplicates, and diagonal threat. That's the problem. Okay.